Next, let's discuss bond valuation using the residual income model. Introducing introduction, reframing bond valuation with residual income. Traditional bond valuation relies on discounting promised future cash flow like coupons and face value at the bond's yield to maturity. In this document, we explore an alternative perspective by applying the concept of residual income model (RIM) to bond valuation. This is purely for illustration. Therefore, we develop a bond residual income model bond RIM that decomposes a bond's value into its face value and the present value of excess coupon payment. So this part determines whether a bond is a premium bond or discount bond. Although conceptually distinct, we demonstrate the bond RIM is algebraically equivalent to the traditional bond valuation approach. This framework not only enriches our understanding of the bond premium and discount, but also provides a pedagogical bridge between bond and equity valuation, okay, as well as our deepen our understanding of residual income model. So bond residual income formulation, okay, in the bond RIM, the intrinsic value of bond, let us denote that a V bond, value of bond, is expressed as a sum of its face value FV and the present value of its residual income. Then the model is formulated as V bond equal FV plus the summation of residual income bond for all future period and with discounted bond, where V bond is intrinsic value of a bond, FV is a face value of the bond. Sometimes it is called par value of the bond. RI, bond I, is residual income in period I. R bound is yield to maturity. Yield to maturity bond acting as the discount rate. So if we know yield to maturity, then it determines a bond. If we know bond price, we have to solve this R bond part. Okay, so it is both discount rate. In equilibrium, they should be same. And its number of period, typically years to maturity. Typically, actually biannual. Okay, here for convenience, we assume it is the annual bond. It pay coupon annually. Now we have to define residual income of the bond. Bond residual income RI bond I represents the excess coupon payment over the required return on the bond face value in period I. Therefore, it is defined by residual income of bond I is coupon rate minus opportunity cost of bond and the face value. This is important. Okay, this is important because this shows that bond residual income model is very useful to price private debt. Private debt is very important class of alternative asset. So in order to find the proper value of private debt, I strongly recommend you to use bond residual income model. Explicitly model the excess return by taking account of the risk of the bond, which R bond here YTM or discount rate would take into account. Well, C is the periodic coupon payments that we know because of contract. Okay, when the coupon C exceeds the required return on face value, which is R bond, opportunity cost of capital for this bond contract, and face value. Face value is actual money we lend, invest. The residual income is positive, signifying the excess return. For bond with constant coupon payment and the constant yield to maturity, the residual income is the same in every period here. So it says that C and R bond, they can be both time varying. They can change over time. Like C can change over time because of contracts. R bond can change over time because of the term structure of interest rate. Now simplify the bond RIM formula with constant residual income. Assuming constant residual income, equation 1 simplifies to V bond equal FV plus summation of RI bond 1 plus R bond. Here we don't take into account the accumulation of book value in the residual income model, which increases with net income minus opportunity cost of the capital. Here they pay out everything. Payout ratio is 100 in the bond contract. Therefore, we don't have to take into account the movement of the book value. Okay, so this is enough. Now, recognizing summation as the present value of an annuity with a standard formula to obtain V bond equal FV plus RI bond and 1 minus 1 minus R bond, something like that. Okay, this is formula. Okay, substituting RI bond equals C minus R FV, V is this one. Okay, so we can only use this formula when everything is a constant, of course. Example calculation: valuing a discount bond using bond RIM. Consider a bond with the following characteristic. Let's say face value FV is $1,000. Annual coupon payment is 80, so coupon rate is 8%. And the yield to maturity is 10%. So yield to maturity is higher than annual coupon payment, so it is likely that discount bond. Okay, years to maturity is 5. Now calculate bond residual income. Bond residual income is of course minus because we receive $80 as a coupon, but yield to maturity is 10%. Face value is 1,000, so opportunity cost is 100. So $80 minus 100 is minus $20. Now calculate the present value of residual income annuity is something like this. Therefore, present value of RI is minus $75. So it is discount bond. Now we can calculate the bond value. Bond value is face value plus present value residual income. Therefore, $924.18. Okay, so it is discount bond. Discount bond means that value of bond is lower than face value. It is discounted. Sometimes value of bond is higher than, sometimes it is higher than face value. In that case, it's called premium bond. When do you think a bond is higher? Bond value is higher than face value, so that it becomes premium bond. Natural, right? When coupon rate is higher than its opportunity cost, right? When residual income is positive, present value of residual income is positive, then it is premium bond. Well, therefore, suppose you are a private equity fund manager and you have a private debt contract. When you value, you have to think about whether this your private debt investment indeed generate positive or negative residual income in future. Okay, you have to take into account its ability, a company's ability to repay its debt and coupon, and then take into account that those factors you have to determine the risk, which in turn determines the discount rate. Here it is R bond. Now comparing with the traditional valuation, well, this is traditional value, the traditional bond valuation formula, which I don't like much. I prefer residual income model, which is bond is the, of course, present value of all coupon payment and then present value of face value. Okay, for our example, yeah, it is something like that, so they actually generate exactly the same answer. Okay, you can check it. Now let's demonstrate algebraic equivalence. To show the equivalence of the bond RIM formulation to the standard bond valuation, expand equation 5. Then we know this equation: V bond FV plus C minus R bond FV, 1 minus R bond to the power of minus n divided by R bond. Expanding the second term, then we have this one. Then we can cancel R bond in the third term, right? We can cancel R bond in the third term. Then we have this equation, okay? Then actually we can reorganize this form, reorganize the terms. Then we have this one, and then simplify the brackets. We have this one. Thus, we recover this one, which is exactly the traditional discounted cash flow formula for bonds. Now, let's extend a bit the continuous time residual income model and its application bond pricing. An alternative approach is to model bond pricing in a continuous time framework, which I prefer. In continuous time, cash flows are assumed to occur continuously, and the discounting is performed using continuous compounding. The continuous time bond RIM can be expressed something like this. Okay, basically same. Okay, again, as I told you, integration is simply summation. Okay, where RI bond T is represented the instantaneous residual income at time T, and big T is the time to maturity. For a bond that pays a coupon continued at a constant annual rate C with a constant yield R1, and the instantaneous residual income is then RI bond T is C minus R bond FE. It is instantaneous concept. Okay, so we have to integrate that. Okay, so it instantaneous, so we have to integrate that to get the actual residual income. Since both C and R bond FV are constant, the residual income is constant over time, the bond value has become something like that. It doesn't have to be. Here we make simplifying assumption. Yeah, simplifying assumption. Evaluating integration is like this one. You can check this one by taking derivative of the left hand item, okay, and the right hand item. They are equivalent. We obtain V bonded FV's initial residual income and then this cumulative part. Basically same. This continuous time formulation mirrors the discrete time bond RIM but uses continuous discounting. It is particularly used for theoretical model and for bonds where coupon flows can be approximated as continuous. For comparison, the traditional continuous time valuation of a coupon bond is given by this one. Okay, we discounted C and FV. Evaluating the integration, we have this one. So that free bond is looks like this. And if we rearrange this one, then we have exactly the same as our continuous time bond RM formula. Then what would be the advantage of the bond residual income formulation? I illustrate that, I explain that the residual income model is particularly useful to price private debt. So while algebraically equivalent to the general bond evaluation, the bond RIM formulation offers several conceptual advantages. Conceptual consistency with equity valuation. It provides a unified framework for understanding asset value by paralleling the residual income approach used in equity valuation. The value decomposition. The model explicitly separates bond value into the guaranteed component like a face value and the present value of additional coupon income, enhancing insight into the source of the value. Okay, that's why it is so useful in private debt valuation. Okay, intuitive explanation for premium and discount. The sign and magnitude of the residual income term RI bond clearly indicate whether the bond is trading at a premium or discount relative to par. Now limitations and then consideration. Despite its pedagogical value, the bond RIM has certain limitations. Model simplicity. The model assumes constant coupon payment and fixed yield to maturity. Bond with a variable coupon, embedded option, or fluctuating interest rate requires more complex treatment possibly. Interpretational analogy. Using face value as a baseline for residual income is a heuristic analogous to book value in equity valuation. It does not represent an accounting book value for bond. Accounting book value is actually more of a market value actually. So practical application. In practice, the traditional discounted cash flow method is efficient and widely accepted. The bond RIM serves best as a conceptual pedagogical tool rather than a replacement for convenient technique. Well, I don't think so. I don't think so. For private debt, conceptually, I think bond RIM is more useful. Conclusion. The bond residual income model provides an insightful reinterpretation of bond valuation by decomposing the bond's price into its face value and the present value residual or excess coupon income. Although this approach is algebraically equivalent to the standard discount cash flow method, it reinforces the conceptual link between equity and bond valuation and offers a clear explanation for the occurrence of bond premiums and discounts. The extension to a continuous time framework further highlights the versatility of the residual income approach and its applicability in advanced theoretical model. This perspective can be particularly useful in academic settings or in discussions involving relative value assessment across different asset classes. In particular, this method is useful in alternative investment, especially private debt.